the shape of the
Every
Earth?
single civil engineer should be able to answer this question.
Okay, what does that have to do with the shape of the Earth? Is what I'm saying.
I don't believe that you're a civil engineer.
Oh, so your point is you want to show me? Okay, that was
Yeah,
good.
my
You
point is that you have no idea what you're talking about.
been called to take your exam. What I'm saying
This was like homework, by the way, for like 18-year-olds.
I really don't care. I just debunked this stupid homework where you don't even give all the information.
You don't need
wanna say,
you don't need
you
that
don't
information.
know.
I can give you the solutions if you want.
I thought you were intelligent. You're just like smug, stupid.
And I thought you were a civil engineer.
But you haven't proven anything by giving me some random thing
Brave
from
boy.
your.
I
you
have
just wanna
proved
show me-
something. I've proved that you're not a civil engineer. Brave Boy Joy Publishing. How's it going, Brave Boy?
I'm doing well. How are you?
I'm doing A-okay. Getting over a cold, though. Brave Boy, what shape do you think the Earth is?
I don't know what shape the Earth is, but I've only seen the Earth flat. That's all I've seen.
Okay, have you seen pictures from space?
All the pictures I have seen have been CGI, and they all look the same. It's almost laughable that you can take
Oh, I can help you with that. Would you be interested in a non-CGI photo?
I no, that's kind of
You
weird.
wouldn't be interested in seeing something that destroys your worldview. Is that what you're saying?
No. I mean, it doesn't. I'm more of a science guy. I don't really get into what
A science guy, are you?
Yeah, I'm an engineer.
Oh, okay, so you're not a scientist, is what it sounds like you're saying.
No, I am. I'm a civil engineer. I am a scientist.
No, you're an engineer, not a scientist.
Well,
Those are different things.
That's true, but we deal in nothing but science as a civil
No, you
engineer.
deal in application. Anyway, let me show you something. If you're a science guy, you should be open to new evidence, right? Let me show you something neat. So this photo, it's a photograph, not CGI. The reason we know it's not CGI is because it existed before CGI existed. This photo is from 1972. What do you make of it?
It's nice. It looks like what I've always believed the Earth to look like. That's what it looks like.
Okay, so you've now seen a photo, a non-CGI photo of the Earth being a sphere.
Yes.
Are you now convinced that the Earth is a sphere?
Those terms that the Earth is a sphere? No. I mean, because I don't.
So what did we just see a picture of?
We saw a picture of what has been identified as the Earth, and what everybody with common sense would say, what is that? And they would say the Earth. Anybody
okay, so you don't think that that's the Earth then?
No, what I'm saying is that's just a representation. It's the
a
same
photograph.
Exactly. Right. The same way somebody puts makeup on and goes out to a play, they represent themselves as, they could be Benjamin Banneker, Abraham Lincoln, they could be anyone they want. Doesn't mean
but this is a photograph.
Yes, that's what it is.
So a photograph is supposed to a photograph.
Yeah.
Depicts the thing as it is, right?
Sure,
as visible by the camera.
Yeah, but we don't. With technology today, I'm not basing my science on a photograph, right? Because
I thought you said that you had never seen the Earth be a sphere, so I just showed you one.
With my eyes, with my own eyes. Meaning, when I
you're an electrical engineer, you don't rely on your eyes for studying radio waves, do you?
What I'm saying is, I'm a civil engineer. When I do whatever I do, I use real life facts and real life experiments. And what you provided to me, that's the same way, like if somebody says, hey, I want you to design this dam, and they give me a picture of where they want the dam is, I actually need to go to the spot where we want to do my own testing. I don't base what I want to do based upon a picture. So what I'm just saying is, yes, I agree with you. That is the picture of the Earth. I'm not denying what you may categorize that. I'm not going to be silly and be like, I don't know what the hell that is. It's a picture of the Earth. But would I use that to say, yes, I can undeniably, in a court of law, say this is a picture of the Earth? I can't do that. But I have questions for you, though, also.
Well, look, so before we change topics, it just seems like we don't rely on just our eyesight to do science. I mean, you said that you're a civil engineer, right? Like like you can't see a force. And yet you use, I imagine that when you were going to school for civil engineering, you learned Newtonian statics, right? You took a course probably called statics. where you
That's cool.
figure out, how much tension is going to be on various wires if they're holding up various things, and you have pulleys and all sorts of things to try to figure out what is the equilibrium configuration. There's nothing that you can see there. You can't see a force, and yet you can still study it. You can still use that information.
Sure. So are you sticking
I don't
to the ground?
So I don't understand why your standard is I need to have seen the spherical Earth with my eyeballs in order to come to the conclusion that it's really spherical. When you can't see forces with your eyeballs, you can't see electricity with your eyeballs, unless it's like arcing, of course. You can't see a lot of things with your eyeballs. That's just not the standard that we use in science.
We can test them though. See, that's the
We
thing.
can test the shape of the Earth as well.
Okay, that's fine. But you didn't give me the test. You just said
Well,
here's a.
that's because the standard that you asked for was being able to see it with your eyes. So I showed you it with your eyes.
No, when you actually go up in the air in an airplane, all you see is flat plane. All you see is the clouds. All you see is the
I beg to differ.
when I've traveled all over the world, and I haven't traveled from one island to the next island. We don't go all the way up in the air. We go up a certain amount of feet.
You go
and
about
we're
7
traveling
miles.
Flat. We're flat. We're flat.
It's not
all
flat
the way
though.
across.
And in fact, we can show that it's not flat by doing an analysis of what we see out of an
It's-
airplane window.
This is what. Okay, so now this is where I'm getting to. So now when you say it's not flat, now we're going to get into what we call you have to do a survey. So
No,
when
no,
you
no.
do
We
a
don't need to do a survey. We can do an
Hold on,
analysis.
Let me just explain my position. If I'm going to do a survey is going to give me the exact height and location of whatever I'm looking at. It's not going to give me false information. So if you're saying, okay, this survey says this is curved, there's no survey that's going to give you a curvature of anything.
Yeah, they will. Actually, this paper does exactly that.
Absolutely will not.
This paper does
I
exactly
deal
that.
with it all the time. There's no curve.
I'm sorry, Brave Boy. I'm sorry. In this case, you're empirically wrong. So this is a photograph taken from an airplane. This is probably what it looks like to you, right? Without the black line and the black dot and stuff. This is probably what it looks like when you're in an airplane at cruising altitude, right?
Something like that.
So
maybe.
what they did is they basically took a line, they drew it across, separating the boundary between the horizon and the ground, the sky from the horizon, and then they drew it across, all the way across, from left to right, and then they zoomed in and they put where the actual horizon is in the middle, and you can see that the horizon is slightly higher. That's what this zoomed in box is here.
Okay.
That zoomed in, the horizon is slightly higher in the middle than it is than what you would expect if the Earth was actually flat. And not only is it just like apparently slightly higher, as is shown in this picture, they actually use this data, the amount that it's higher, as well as the field of view of the camera, to predict the field of view of the camera and the height of the plane, to predict precisely how large the Earth is. And what they find is that it's exactly the amount of curvature that they observe in this photo is exactly as much as you would expect from a spherical Earth.
That's why we would never use a camera.
Did you listen to what I said?
Absolutely.
Can you repeat back to me what I said?
You're saying that the camera and the camera lens and the is going to give me some sort of depiction of why the Earth is curved. And what I'm saying is, in real life, meaning when we actually use something in real life, we would never go to a picture. Like I told you,
you absolutely would. Wait, are you saying that you make your measurements, like when you're surveying for like a dam that you're trying to build? Are you saying that you make your measurements with your eyeballs, or do you actually take
With
digital photographs and make
No.
a camera's a type of
small.
instrument, my guy.
No. We're talking survey instruments are not, we're not taking photographs, sir. We're taking
a camera is a type of surveying instrument.
Okay, what I'm saying is a camera is also it has a focal length which is skewed. It doesn't give you
It
an
does.
exact.
Unfortunately, they accounted for that.
There is no accounting for.
Yeah, you can. So this is what happens if you have the horizon above the center. This is called barrel distortion. This is what happens when you have the horizon up. Please, I'm in the middle of a sentence. I'm in the middle of a sentence. So
Okay, I'm sorry.
the distortion that you're referring to, the focal length, blah, 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 the distortion that you're referring to is captured here. If you have the horizon above the middle line, you will get this kind of distortion. It curves up. This is what happens when you compress it horizontally. Similarly, when you have the horizon along the middle line, you get minimal distortion. And when you have the horizon below the middle line, you get curvature down. However, so what this means is that if you put the horizon in the middle, then you are getting no distortion. That is an accurate rendition of what's actually happening. And so they put the horizon in the middle of the frame. And so there's no distortion here.
I've built so many things, and I've never, ever, for everyone on TikTok, ever took a picture of something and used it as a representation to say, hey, I'm gonna put my PE stamp on this because I took a picture. Absolutely not. We take actual.
Then you don't use cameras in order to run your analysis. That's fine.
Excuse me. Hold on. We use actual data, and so all I'm saying is.
I'm sorry. What's this? Is this actual data here on the right? Is this actual data on the right?
Can you give me a second?
You can use photos to generate actual data.
Okay, can you give me just 1 second?
Do you understand that?
Sure, absolutely.
Okay.
I'm engaging
that's
with
what they
you.
did. That's what they did.
Okay, I'm engaging with you. What the first thing I want to say is that you're just because you have data, I have data, right?
What's your data?
I have a couple questions that I'd like to ask. That's the point I'm trying to get to.
What's your data? You said that you have data. I have data. What's your data?
I'm saying if I have actual survey information, meaning, I'll give you an example. Have you ever heard of maps? The what is it? Oh my gosh, it's slipped my mind. Anyway, the actual geographical oh my gosh, it's slipped my mind. Anyway, the actual survey data to build any, like for instance, any bridge that you build, you're going to have to build from one point to the next, and those 2 points in which you're building those that they're actually touching the land. They're actually level. Now the bridge may go
Wait,
up.
sorry. Do you have evidence of that?
Hold on, let me just finish what I'm just saying. The bridge can arc up, meaning that it can go up into the air, but it will come back down and come on level ground. It's not even a matter of do I have any evidence. Just ask, do you build a bridge?
So you don't have evidence is what you're telling me.
Can you just let me just finish this last point? I let you say.
Go ahead.
Okay. So the point is, you can't build a bridge that's at elevation 0 and go up to elevation 10. You're not going to build a bridge up into the air. You're always going to build a bridge at elevation 0, and on the other side, it's also going to be elevation 0. Now, if you can show me, you do this. You show me a bridge where it goes up in elevation. Not the height of the bridge, not the crest of the bridge. I'm talking about the two ends of the bridge. Show me where those two ends of the bridge are not the same. Show me.
I'm sorry. Do you think that if the
As
Earth is
an
curved,
engineer, I'm asking. I'm
answering your question, Brave Boy.
Show me
Brave
one
Boy,
bridge.
do you think that if the Earth is curved, that means that one end of a bridge would be at higher altitude than another end of the bridge?
What I'm saying to you is that there is.
Can you answer that question, please? I'm trying to clarify what you're asking for.
I don't know. What I'm saying is I only know what is available to me. And I have not seen any curve. Okay, what I'm just saying is if I haven't observed a curve, is that my fault?
Well, I just showed you some.
No, I mean, I'm just showed you a picture. In my profession. I'm talking about when I actually have to go out and actually build something. I've never, ever used
Give me an example
gravity.
of things that you've built.
Hold on. We haven't never used gravity. We've never used gravity one time. We don't use gravity.
I'm sorry.
Yes.
I'm sorry. You're saying you don't use gravity? So what is the so you've taken a statics course, right?
I've taken all engineering courses. Yes, of course.
Okay, so you've taken a statics course. Yes. So when you have a let's say that you have a bridge that is suspended or that is supported on two sides.
Yep.
Between like two vertical poles, say. So you have two vertical poles, you have a bridge suspending them. So what are the forces acting on the bridge?
What are the forces acting on the bridge?
Yeah.
I mean, there is going to be a down force. There's going to be a down force on the bridge, which is 32.2 feet per second, 9.8 meters squared per second.
That's not a
Whatever
force.
you make. Come again?
Those are accelerations, not forces.
Well, okay. Well, that's the only thing that's acting on that bridge. There is no.
I'm sorry, you're missing one. Are you sure that you are an engineer? Because there's
absolutely.
There's
what are the forces
there's
you're
four
about?
forces, or there's three forces in this case. There's
Okay,
the
what
downward
force
force
is
at the center of mass, right? This is the
that's
force
what
due to
I did.
gravity. Then
That's
there's
what
two upward forces at either of the support points. These are normal forces.
Okay, what I'm saying is, what you have to also understand, like the normal forces are. Do you even account for that?
Yeah,
They're
you absolutely have to
regular.
account for the normal force. Otherwise, the thing would be moving.
Okay, so you're saying that if I put 100-pound weight on something, then 100 pounds needs to be forcing upward?
Yes, that's what the
Absolutely
normal
not.
force is.
Okay, all right. So let me ask you a question.
Hold on. Before we continue, I really gotta verify something.
Sure.
One sec. Want to make sure that this is visible. Okay. I really got to check something. Can you answer this fourth question?
Oh my gosh. What's the fourth question? I can't even see it. What's it say?
You can't see it? It's on your phone.
No, I'm looking on my phone. I can't. I have my glasses on and everything. It's so small. Fourth question, number 4. What does it say? A car is moving down a flat horizontal highway at a constant speed of 12. Is that meters per second?
21 meters per second, when suddenly a rock dropped from rest straight down from a bridge crashes through the windshield. The rock strikes the windshield at a right angle, and the windshield makes a 60-degree angle with the horizontal. Can you find the speed of the rock relative to the car when it hits the windshield?
Oh man, you sound like I'm about to take my PE again. Listen, I have no clue what you're trying to get from, and I mean, I'm not saying any of these things you can't get the speed or anything. What does that have to do with the shape of the
Every
Earth?
single civil engineer should be able to answer this question.
Okay, what does that have to do with the shape of the Earth? Is what I'm saying.
I don't believe that you're a civil engineer.
Oh, so your point is you want to show me? Okay, that was good.
My point is that you have no idea what you're talking about.
Oh, you haven't even let me say anything.
Okay, so what's the answer? How would you solve that problem?
Oh, give me back the equation.
Mm-hmm.
It's saying it hit a rock. Suddenly a rock dropped from rest straight down from a bridge.
Mm-hmm.
Straight down from a bridge. If it's over a bridge, how did it hit the car? Where's the car?
The bridge is over the road.
Okay, so crashes through the windshield. The rock strikes the windshield. I mean,
Yeah.
it's a mass balance. I mean, it's a force mass balance equation. But you know, I'd have to think about it. This is an interesting question, but I'm not exactly sure what that has to do with the shape of the Earth. That's what I'm saying.
Just because it's pretty clear to me that, like, I don't even think you know how you would start this problem.
Okay. You tell me how you would start it.
Yeah. So what you would do is you would work.
Okay. Let me.
So what you would do is you would work in the reference frame of the car.
What you just
know
did
the angle.
was show me.
You know the angle at which the rock is striking the windshield. You know the angle of the windshield, which is 60 degrees, which means that because it's striking the rock strikes the windshield at a 90-degree angle. You know that from the reference point of the car, in the car's reference frame, the rock is moving at a 30-degree angle. Now you have a right triangle. You know the vertical speed, which is 20, or you know the vertical speed, which you can.
You know what's so silly? You haven't even told me how far the rock is falling. So that doesn't.
I'm sorry. You don't need any of that.
You absolutely do. How?
No, you don't.
Because
You don't
rock
need the
is
height.
going to be excuse me, sir. The rock will be accelerating. Of course, you would need to know how fast the rock was. The rock, if the rock
you
is
don't.
going to be,
you actually don't. That's the lovely part.
Hold on. So you're saying that the rock is falling from the bridge, it's not going to be accelerating down?
No, it is accelerating. You just don't need to. You just don't need to know that in advance.
You would need to know the speed of the rock. You would need to know the height of the
No,
bridge.
you don't. No, you don't. You
So
want me to
how
show
would
you
you
the
know how
answer?
fast
I
the
can
rock
actually
is
show you the
going?
worked answer if you want.
You're on this like.
Do you want me to show you the worked answer? I can show you the worked answer. I think it was
What I'm
the
saying
homework
is,
assignment
this
that I
has
assigned.
nothing to do with what I call. I didn't call to take your exam. What I'm saying
This was like homework, by the way, for like 18-year-olds.
I really don't care. I just debunked this stupid homework where you don't even give all the information.
You don't need that information. I can give you the solutions if you want.
Bro.
Yeah, here's the solutions.
Yeah, I mean, listen. Answer my question. How come Antarctica gets 5 months of sun and then 5 months of darkness? What is that about?
Because it's on the South Pole.
Okay, so let me get this right. Are you sticking to the ground?
By the way, just for everybody, just so everybody can see. One sec. I will answer your question in a moment. Here's the solution that my grad student wrote up. In the car's frame, the car is moving to the right. The windshield is 60 degrees. The car has a velocity of 21 meters per second, which means that relative to the car, the rock is moving horizontally at 21 meters per second. And so you can use the angle, which is known to be 90 degrees relative to the windshield, and basically the shape of a right triangle to establish that the relative speed is 14 times the square root of 3 meters per second. You don't need to know how fast the rock is going. You can actually find how fast the rock is going. Anyway,
how do you find out how fast the rock is going without knowing how far it fell? That's how.
Because you know the angle that it makes with so you didn't understand. I understand that.
I really thought you were serious.
So you don't know. You don't understand it, and that's fine. I can explain it for you. The point is, you know what its horizontal velocity is.
Leave the equation up there so I can just tear it apart, sir.
Yeah, go ahead, tear this apart.
Okay, first of all, thank you. So you're saying you're asking where's the velocity? How fast is the rock going?
You don't need that information to solve this problem.
What equation are you using? What equation?
You're using right triangles. So we know what the
right triangles is not an equation, sir.
Yeah, essentially we're
what
using
is the equation.
We are using the definition of the sign. This is basic trigonometry.
I'm stupid, but I'm sorry. You're right.
Do you want me to explain it to you again?
No.
So
show
we know.
Me. Don't
we know. I'm showing it to you right now. I am.
You said you guys that you said your third grade. See, this is what I'm saying.
So
here, like foolishness.
So in the car's frame, this is a diagram of what's happening. We have that the car is moving to the right at 21 meters per second.
Where's the formula?
Classic engineer only understands formulas, doesn't understand diagrams. I get it. The car is moving to the right at 21 meters per second, which means that the rock from the car's frame is moving to the left at 21 meters per second. You want to find the relative velocity. Now we know that the angle of the windshield is 60 degrees.
Velocity?
Yeah. That's what the question asked. We know that the angle is 60 degrees, obviously not drawn to scale here. So you can use that. These are basic trigonometric facts that you can find the angle here between this being 60 degrees and that being 60 degrees, and then you can just use the definition of the sine.
You're making so many assumptions.
The sine of 60 degrees.
Of the windshield.
You don't need any of this.
You have to know how fast.
You don't need any of this. You don't need any of that. You just need to know that the sine of 60 degrees is equal to the velocity of the car divided by the velocity of the rock relative to the car. That's all you need. That's a basic trigonometric fact once you draw out the diagram, and then you can solve for the velocity of the rock.
How heavy is the rock?
That's unrelated to the speed. It's unrelated to the speed.
I didn't come up. Okay, so let me get this right. I'm the first person.
And you're a civil engineer.
Actual engineer.
Oh my God! Bridges that you build are going to collapse. This is so embarrassing for you.
It's so embarrassing that you gave me a test. That was good. I love that.
Like, okay,
And you
so
failed.
your job is when you find somebody who actually knows what they're talking about, you give them a
But you
test that is
don't. But
erroneous.
you don't know what you're talking about
But
because
you
you couldn't
don't know what you're
solve
talking about, 'cause it's on
so I've
TikTok.
assigned this homework assignment specifically. I've assigned this
I
homework
don't
assignment
care what you
to
assign. Your
18-year-olds
students are
2
actually must
weeks
be
after they
stupid.
start.
I
2 weeks
really
after
don't
they start
care.
college, they're able to
You
solve
haven't
this
shown me
question.
one formula. Oh, you just showed me an angle, and that's supposed to mean something?
Here's a formula. Here's a formula right here. The velocity of the car divided by the relative velocity. The velocity of the car divided by the relative velocity of the rock with respect to the car is equal to the sine
where
of
did you
60
get
degrees.
that formula from?
From basic trigonometry.
The relative velocity divided by the velocity?
The
is gonna
velocity of
give
the
you
car
sine
divided by the relative velocity of the rock with respect to the car is equal to the sine of 60 degrees.
That's going to give you okay. Velocity divided by velocity is going to give you. You're
These
going
are
to
two
cancel
different
those terms
velocities.
out.
These are two different velocities.
and
One
those-
is the velocity of the car.
and
The other is
and
the relative velocity of the rock with respect to the car.
And they're going to cancel each other out. So
No,
what
they're
is your
different
point?
velocities. They're not going to
In
cancel
a-
each other out.
in
The
a
velocity
ba-
of the
in a
car
balanced
is one
equation.
leg of a right triangle. The relative velocity is the hypotenuse of the right triangle. Use your Pythagorean theorem. They can't be the same number.
Use my that's not a formula, sir.
The
I mean,
Pythagorean
like,
theorem is
you're just
absolutely a
you're-
formula.
Like absolutely, you're like somebody who's trying to be intelligent, but you don't know how to be intelligent. You're just like use your
This is so embarrassing for you. You couldn't even solve
it's
the
embarrassing
first
for you
part
because you're
of a
on
freshman
demonstrating to
engineering
everybody who's
physics
listening,
course.
They're begging you to show me
This
something
is so
that's actually gonna mean something.
embarrassing.
Okay, so let me get this right. You want to tell me it's embarrassing that I don't know some random equation that we're talking about the flat Earth, and so you divert from what we're talking about to go to some random equation to say it's embarrassing.
It is embarrassing that you don't know basic
how
it's
transparent
embarrassing
you are.
because you don't
are
know basic
fake.
kinematics and you claim to be
You
a civil
are
engineer.
fake. I thought you came with you had some intelligence. You're just like faking, like, oh, okay, I'm just here to just own and embarrass people. I'm not here to actually talk real science.
I'm sorry.
I thought you were coming here to talk real science.
Do you think that like Newtonian kinematics is real science?
We don't use Newtonian anything in real life. Nothing.
I'm sorry.
Nothing.
What do I don't know? Artillery engineers do when they try to figure out how far away
we use
a
regular
rocket
physics.
will land.
They use
That's
regular
Newtonian.
physics.
That's
Show
Newtonian
me an
kinematics,
equation
dumbass.
where they use Newtonian. Once again,
Do you know what
you're
Newtonian kinematics
You're
are?
so intelligent. Show me an equation where they use anything Newtonian or anything different jabbers you're talking about.
Do you not know what Newtonian kinematics are?
Do you?
Yeah,
Do you
Newtonian
know what they
kinematics
are?
are
You're
things
saying
like
it, but do you know? What is Newtonian kinematics? Tell me what it is. Tell me
so
what it is.
Newtonian kinematics are just the kinematics of Newtonian physics, which are also known as mechanics.
What is Newtonian physics used for?
Newtonian physics is used for literally your entire job. That's like
We don't
balancing
use
of forces.
anything
That's Newtonian
Newtonian.
physics.
How you want to
Balancing
tell me what I use for you? Show me one thing.
You're a civil engineer. F equals ma, my guy. F equals ma is Newtonian kinematics.
Yeah.
Actually, that's
No,
Newtonian
that's
dynamics.
just
Well,
normal
yeah, that's
physics.
kinematics.
Forces
That's
and mass
Newtonian
times stuff,
kinematics,
that's
my guy.
normal physics.
Or
But
rather,
even
that's
that
dynamics,
has to be
more
applied
specifically.
in some fashion. You just can't say mass times accelerator. You have to apply it because depending on the type of situation, it's going to be different. So you're just rambling off. F equals ma. Anybody can know that from physics. You're not even.
That's
I thought you were
Newtonian
intelligent.
mechanics.
I thought you were intelligent. You're just like smug, stupid.
And I thought you were a civil engineer.
But you haven't proven anything by giving me some random thing
Great
from
boy.
your.
I
you
have
just wanna
proved
show me-
something. I've proved that you're not a
just
civil
wanna show me something
engineer.
From your grad school.
I've proved that
Is
you're
that
not a
what you
civil
were trying to
engineer.
do?
Or if you are a civil engineer, you haven't used your brain in 30 years.
Listen, at this point, your point is just to deep. Your point is not to actually talk about what we're talking about. Your point is just to say, oh, well, hold up. This guy's qualified. Let me sort of like make him unqualified. Oh, you think you're this. You think you're that. You're just like you're like a babbling fool. Like TikTok, I thought TikTok had intelligent people. You're using no intelligence.
Keep on crashing out. It's fine.
Insulting. No crash out, buddy. No crash out.
You don't think that was a crash out? That was a crash out.
Bro, I'm just saying you're doing nothing. There's no crash out. You haven't answered one of my questions.
Brave boy, the reason why I asked you that question is because you made the wild ass claim that you never use gravity as a civil engineer.
I
And the-
said, listen,
which is a
to me.
crazy claim, because of course
Can
you
I-
do.
can I
That's
clarify?
how you compute the weight of
clarify?
something. You
Can
may
I
clarify.
clarify?
Yes.
Okay. Now we're talking about discussion. Gravity, what is gravity? What is gravity?
Gravity is the observed phenomenon of mass attracting mass.
Exactly. And what I'm saying is there's never a situation where one mass is attracting another mass.
I'm sorry,
And
what do you
that's
think the
why-
Earth is?
Hold on.
Is the Earth a mass?
Let me just finish what I'm saying, sir. Let me just finish. Instead of you just like, it's just like this craziness.
I'm sorry, do you think that the
There's
Earth
no-
is a mass?
Hold up. What I'm saying is I do things inside the earth. I don't do things outside the earth. Oh,
What does
hold on.
inside the Earth mean?
Meaning water, air, wind.
Those are inside
Earth.
the Earth? Well, look,
Yes.
is the Earth a mass or not?
It's a system.
Does the
Earth
Earth
is
does
a
the Earth have
system.
mass? Like the ground, the rocky bit, does that have mass?
If I dig it up, that's the mass. I don't
Does the
use the
Earth
whole
have
earth.
mass? Does the Earth
The
have
earth,
mass?
dirt is mass. I don't say
The
hey,
whole okay, so you know how there's dirt below you, and then there's dirt to the either side of that, and if you
Yeah.
keep digging down, there'll be like more dirt and rocks, maybe, and maybe lava
Yeah, but we
eventually,
don't-
or
we
something
don't-
like this.
in
So
real life-
all of that stuff,
Yeah.
does it have mass?
It's mass. What I'm saying is
Does
not
it-
being attracted to anything
You
else.
didn't answer my question. Does it have mass?
It's not attracted to anything else. What
Does
is
it
it
have
being
mass?
attracted to?
I'm sorry. Does it have mass?
It is mass. It is
That's
mass.
a category error. Does it have mass? Things aren't mass. Things have mass.
Well, I'm just saying the dirt has a mass. Right. it
Yeah,
has
and
a
so
mass.
the sum total of all of the dirt over the entire Earth has mass, right? And all of the rocks and all of the lava, all that stuff has mass, right?
Sure.
So, and when I take a little cube, this has mass, right?
Yeah. But that's not gravity. You
And
keep saying
I'm sorry,
mass.
I'm not done yet. I'm sorry, I'm not done
Okay.
yet. This has
Go
mass.
ahead.
And so when I say
Yeah.
the phenomenon of two masses attracting each other and I drop this, are those two
Yeah.
masses getting closer together?
They're not attracting each other.
I'm sorry, are those two masses getting closer together?
Not attracting each
Are
other.
those two masses getting closer together? I'll ask a third time.
You drop
those
any
two masses
object,
getting
it's going to
closer
go
together?
straight down.
Are those two
That's
masses
a
getting closer
phenomenon.
together?
You're not being smart. It's a phenomenon.
two masses getting
Anybody
closer
can do
together?
It. A cloud can do it.
Are
A
those
cloud
two
can do
masses
it.
getting closer together?
Are they attracting each other? No.
That
Is
was
it
my question. Are
falling?
they getting
Yes.
closer to each other? Are they getting
No.
closer to each other?
No.
They're not getting closer to each other. So you're
the
telling
one
me.
you drop
So
is-
to be clear,
is
and I
approaching
just got to
the one
mute you
on
for a
the
second
ground.
because I just want to clarify this. So to be clear, you're telling me that when I drop this, it's not getting closer to the ground? Is that what you're telling me?
That is the mass. The object that you drop is getting closer to the ground. But
Right. And what do you call
not
it when
getting-
two things
the
get
object.
closer to each other?
they're not getting closer to each other. What I'm
Sure they are.
saying. So are you
The distance
saying
between
that
them is shrinking, is it not?
So how is that applied in civil engineering? How is dropping something applied in civil engineering, Brainiac?
Well,
How is it?
Typically,
How
you
is
want
it-
things to not drop, so you have to take into account the force that is pulling it to
Show me
that
the
wants it to
equation,
drop.
sir. All the like what I'm saying is in real life.
Here, do you want me
you're
to
gonna
show
get
you
caught.
examples of
You're getting
statics
yourself
that use
caught
this?
because there
I can
is
do that
nothing-
if you want.
Is-
Here, one
is-
sec. Let me pull up. Let me show
Hold
you
up.
some equations. You want equations? We can do equations. I love equations.
No, I don't want equations.
I thought you just said show me the equations.
What I want is you just.
So
to
should I
answer
show
my
you the
question.
equations or should I not show you the equations?
Is it? Hold up. What is this like? I won't.
Do you want
I'm
the
not gonna
equations
have
or
a
do you not
serious
want the
debate.
equations? Yeah, so here we
I'm
go.
trying
Here's
to
some
have a
equations.
serious debate.
No, you're not.
But I realize you're not serious. You're not a serious
So
scientist.
here's a homework problem. This is from week
I don't
7.
need another homework problem.
Apparently you
Did
do because you
anybody
got to
else?
practice.
You got no.
This is a
you gave no
statics
one else
problem.
your homework. Why
So-
you give me homework for?
Because apparently you need to practice. Maybe you should go back and
I
take
honestly
your
don't.
qualifying
don't
exam.
need- Are you sticking to the ground?
So if we have
you
a
sticking to the
construction
ground?
crane with
Since
a
you're
load
dropping,
of
are you
2,000,
sticking to the ground?
if we have a construction crane with a load of 2,000 kilogram cargo, A construction crane has a load of 2,000
No, you
kilogram
don't,
cargo
right?
container on one side of
is
its
that?
lifting arm and a tension wire on its other side to support the weight.
I'm not
The
angry.
crane's tower is 20
very
meters from the end of the lifting arm and 10 meters from the tension wire. The tension wire makes an angle of 15 degrees with the vertical. The lifting arm of the crane
going
has a
on
mass
is
of
Dr.
1,000
Bliss
kilograms
is
and
giving me
the
homework.
mass is uniformly distributed. By the way, I turned your volume down, so your volume is much quieter than mine. Now, question 1. What are the forces on the lifting arm of the crane? Do you know how to find the forces on the lifting arm of the crane?
That's civil engineering, right?
This is statics, yeah.
Well, it's civil engineering. They blend in. But what I'm saying to you is, are you sticking to the ground?
I'm sorry, what are the forces on the lifting arm of the crane?
No. Are you? You're not sticking to the ground? You're not sticking to the ground.
I'm
Does
sorry.
water stick to
What are
the
the
ground?
forces
Nope.
between the lifting arm, or
Water
what
can
are the
only be
forces
in
on the
something
lifting
that's a
arm of the
bowl.
crane? Okay, well, look, I guess you don't want to answer because you don't know how. The second
No,
question
I
is,
do.
what is the magnitude?
I understand trusses and
What is the
and
magnitude
static
of the
force.
tension force on the tension wire? This is the wire here. What's the magnitude of the tension force? Now, we can actually just go pull up the we can
You're
just
doing.
go pull
hold
up
on.
the homework
Can I
solutions
ask,
if you want.
Can I ask you a serious question? Can I ask you?
You
a
can
serious
ask me
question?
whatever you want.
All right. Now,
Here's the homework, by the way. Here's the solution.
Geospace.
So we have a whole bunch of different forces here. So look, hey, look, it's an equation. Look at that equation. Isn't that a lovely equation? And we can
What
even
does it
solve
mean?
for
I
the
mean,
equation to get
what does that mean?
46.4 kilonewtons. Isn't that great?
We don't use newtons.
Oh, I'm sorry. I thought that we were talking about science. You use foot
Yeah.
pounds?
Yeah, foot pounds. Yeah, I mean, you could convert it into newtons, but I'm just
Or I'm
saying.
sorry,
in
no,
a
you
general
use
sense.
pounds force, not foot pounds, because foot pounds is a torque.
Okay. Yeah. I mean, yes, of course.
So,
yeah.
so newtons is what scientists use. I would imagine
No,
that that's what
I-
you use during your degree. Now, these are all
no,
equations, and I'm sorry,
saying
what's that little g there? What's that little g?
Milligrams per liter. Is that what you're doing?
What's the little g there? You don't know?
grams? That's weight, right?
Oh, what you think that the G stands for grams? Well, I'm sorry, we have the force equals mg, F equals mg. What does the G stand for?
Is that gravity? Supposed to be
It is gravity. So it does show up in your job. I'm sorry.
Okay,
This is
hold on,
this
okay,
is a statics diagram. This shows up in your
Yeah,
job.
okay.
I understand. Maybe
No,
you just you just ship it
G-
off to computers nowadays. You don't actually think anymore. But this is part of your job.
Dr. Blitz. So you said gravity is attracting. Where's that G attracting to anything?
It's
G
attracting
is
to the
just a
ground.
downforce. No, sir. See this is where a real engineer teaches you a little something. G is just a downforce.
Yeah, what
And
kind
G
of
is a
force is it?
downforce that's done
What is the
everywhere
origin
over
of the
world.
force? Yeah,
Are
what
you
is the
sticking to
origin of the
ground?
force?
Are
What
you
is the
sticking to the ground?
Of course
Are
I
you
am. What is
sticking to the
what is the origin of the
Let me
force, my guy?
Answer my question, yes or no.
I
Are
already
you
said.
sticking
I
to
said
the
of
ground?
course. I said of course.
You are sticking to the ground?
Yeah.
So right. So you mean that that force that's sticking you to the ground, I can't lift you up because that force is sticking you down, right? Of
No,
course
that
not.
doesn't follow.
Because you're not in a gravitational, you're in a buoyancy.
I can't believe that you actually passed a
Whatever-
physics
whatever-
1 course
I'm just
without
asking you a
understanding what
question.
net force
I can't
is.
believe you can't answer a simple question.
I've already answered your question. I answered. I
have not
answered. Of
answered
course
my
not. That doesn't
question.
follow. I already did. You just didn't pay attention.
I just asked you a question.
I answered your question, and you just didn't. I guess you didn't hear
said,
it.
do you stick to the ground?
Of course.
So you have to lift your foot off every time you lift it up because your feet is being stuck to the ground?
Yeah, you have to apply it. You have to apply a force to lift your
Absolutely
foot
not.
up.
Okay, so let me ask you. So since the ocean, yeah, you're right. So the ocean, which is tons.
You should
and-
get your money back for your degree, by the way.
Okay, thank you for the insult. So you're saying that the water is
It's just advice.
water that weighs a billion tons is being held down by gravity, right?
Yeah.
It's sticking to the ground, right? So that same force that's holding all that ocean back is holding you down.
Yep.
Yet you're able to just float around and jump up and down, right?
Yeah,
that
because the
really
force is
makes
proportional
sense,
to the
sir.
product of their masses.
Right,
So if you have
that's
a heavier
gravity,
thing,
and that's what
if
we
you have a
don't
heavier
use.
thing,
we don't use
so
any.
brave
we
boy,
use the downforce.
brave
we don't
boy,
use anything as
you use
gravity.
F equals mg, right? You use F equals mg,
What does F equals mg mean?
and you have an engineering degree, a civil
I'm
engineering
asking
degree.
you where, and you can apply it everywhere. What do you? Your point is okay. I got you. Your point is just a talk about my engineering degree. I got you. I see what you're saying. Okay,
You,
good.
it,
No, no,
it's
no,
just
no. I know.
like,
I'm.
hold on. I
no,
have a friend who's actually a civil
no,
engineer.
I don't care about your
Let me-
friend.
let me
We're talking
text
about
him.
the flat Earth. We're talking about. You wanted to. I came up here to talk about, and now you want to talk about.
You
want to give
came
me
up here and I came
problems?
up here and to talk about, and like, look, bro, if you don't remember your civil engineering courses, that's fine. Like, you can
I'm
just say
asking
that.
you a question.
But like,
you said,
this is
you
like
said,
fundamental to your field
why does Antarctica get 5 months of sun
because
and
it's at
nobody
the South
nowhere
Pole.
else gets it?
Do you want me to show you a diagram? I can show you a diagram if you want.
Don't show me anything. I'm just asking questions. I'm just asking questions. Why does the moon show up in the middle of the day with the sun being out at the same time?
Because the moon doesn't follow the orbit of the sun, or the orbit of the Earth,
They're
rather,
out
I should
at
say.
the same time. A
Yeah,
crescent
they can be out
moon
at the same time. Yeah.
and a crescent moon. So does
Yeah.
the hold on? Let me get this right. So you also believe
Seems like you're
that the
confused.
sun. Hold on. Do you believe that the sun is casting its shadow on the Earth and that's creating the crescent of the moon?
No, that's not what.
Oh, well,
that's
how
not
do
why
you
the
get the
moon is a
crescent on the
crescent.
moon?
It's the
How do you get
shadow
the crescent?
from the moon itself. Do you not
The
understand
shadow-
this?
Okay. Oh, here's a great one.
How do you
All right.
not? Hold on. No. We're not
No,
gonna.
no,
We're
no,
not
no,
gonna
no, no,
pivot.
no,
I can't believe you don't
no.
understand this.
I let you give me 1,001. Listen,
No. But
let me ask
we
you a
should talk
question.
about
Do
this
you
because
believe
you
there's
clearly
water
don't
on
know
the
the
moon?
answer to it.
Is there water on the moon? Is there water on the moon?
I don't think that there's liquid water. There might be ice. I don't know.
Okay, so there might be ice on the moon, right? Because of
Maybe.
cold,
I don't know.
Now, let me ask you a question.
Hold on. We're not
How
pivoting
is that
off from this thing.
Hold
Do you
on.
think that
Hold
on
on.
the
Let me finish.
globe
Let me
Earth?
finish. Let me finish.
No.
Sir.
We're not. I'm sorry. I'm not letting you finish. We're going to talk about the
Okay.
thing that you brought up earlier.
The
You think?
specific gravity
Do you think?
of water.
I'm
the
sorry, I have to
specific
mute
gravity
you.
of water.
Do you think that the reason why, at least under the globe model, why the moon has phases is because the Earth is casting a shadow? Is that what you think? Is that what you think we think? Because that's not what we think. You can unmute now.
I'm just asking questions. I'm not
Okay,
here to.
so do you want to know the actual
That's your job. Your
explanation
job is
in
to
the
rate
globe
me.
model? Do you want to understand what the globe
the-
model
the
says
globe-
is the cause of the crescent shape of the moon at different times of the month? Do you want to know the answer to that?
No, I don't.
Hold on. Then why the hell did you ask the question if you don't care about what the answer is?
What I'm asking you is that it is a belief that the sun casts a shadow on the moon. And it's impossible for the sun to cast a shadow on the moon if I see a crescent moon out in my sky and
so
the sun.
you say
Hold on,
it's impossible, but you just don't want to know how it's possible, I guess.
Hold on. Let me just finish what I'm saying, sir. I'm giving, because everybody in the audience, when they go out, and especially at this time of year, they all can go out and see the sun and the moon out at the same time. It's not like I'm saying something crazy, because we've all seen it. And what I'm saying is, when the sun and the moon are out at the same time, it's impossible for the sun to be casting a shadow on the earth and then see the moon in a crescent form, because they
moon's
would be at
crescent-
two different places.
The moon's
It's
crescent.
impossible.
The moon's
It's
crescent is not from the
impossible
Earth.
for the sun to cast a shadow.
The moon's
onto
crescent
the
is not
earth.
from the Earth. Do you not understand? Like the moon is casting a shadow on itself. Like there's the backside of the moon that isn't facing the sun. Please, I'm in the middle. I'm in the middle.
How do you
I'm in the
cast
middle
a
of
shadow on
explaining this.
yourself? That's
So
that's an
yeah.
impossibility.
Yeah. So Brave Boy, use that noodle of
How do you
yours.
cast it? No.
I'm gonna answer your question.
Yes.
Pay
that's
attention.
that's a big one. You
Pay
cast
attention.
a shadow on yourself.
Pay attention. Okay.
I am. I'm listening.
Okay, you're paying attention. Great.
Malarkey.
I actually should have like a good demo here, but I don't. So when you're facing the sun, your face is lit up, right? Is the back of your head lit up, or is it in shadow?
It's in shadow.
And what is casting that shadow when you're facing the sun?
No, a shadow is not being. The shadow's being cast onto the ground. There's nothing.
I'm asking, why is the back of your head dark when you're
because
facing
it has
the sun?
no light.
Right,
Because it
that's
has no
why,
light.
and that's why
It's not casting a shadow. It has no light.
That's what a
It's
shadow
not a
is.
shadow.
When you're in a shadow,
No, it's not
that's a place where
casting a
light is
shadow,
being
sir.
blocked.
Sir,
That's
it's
what a
not
shadow
casting
is.
No.
A shadow is a region where the light is being blocked from a light source.
No. A shadow
that's
is
not
from
what a
a
shadow
light
is?
source that's cast onto something else. You don't even. Yeah, there you go. It's a
So
little smirk.
a
'Cause you don't even know
shadow
what you're talking
is a
about.
region where light is being blocked from a light source by some opaque object. That's what a shadow is.
Yeah, right.
It's an absence of light
I can't cast a shadow
caused by the blockage of a light source.
Hold on. It's impossible for me to cast unless my hand could cast a shadow onto a part of my body. But what I'm saying is my body's not going to cast a shadow onto
The front of your head is casting a shadow on the back of your head.
Actually, it's not casting anything. It's in the dark.
Okay. So then in the same way,
is projecting.
I understand that you don't like that language, so I'll just change the language so you're more comfortable. In the same way that the front of your head is blocking light from the back of your head, which puts the back of your head in the dark, the front of the moon blocks the light from the back of the moon, so the back of the moon is in the dark. That's why you get phases of the moon.
Oh, okay. So you're saying that when the sun is out and I'm seeing the sun at the moon at half crescent, that you're saying that somehow I can see the dark part and I can see the light part.
Well, no, you can't see the dark part because it's dark. That's why you can't see it.
Actually, in the daytime, I actually can see through the dark part and I actually see the sky. And I see the part that's not shown on that crescent part.
No, you don't see the dark part at all. The dark part's not giving off light, which is why you don't see it.
Because I actually see the part that's circular, and everybody can. There's nothing I'm saying that's weird. Anybody who could go outside and when they see the moon during the day and they look, they'll see a transparency between where the crest was supposed to be.
Oh, I see what you're confused by. You think that the moon is below the sky, but the sky is between us and the moon.
No.
And so the sky, because the sky is blue, whatever is not emitting light will look blue, which is why the part of the moon that you can't see looks blue because the moon is the moon is beyond the sky.
That's a great explanation, but what I'm saying is, as an earth scientist, I really
You're not an earth scientist.
I don't care about what the moon. I don't know anything about the moon.
I know you don't know anything about the moon.
Yeah, right. And I claim I know everything about the earth. Right?
I don't think you know anything about the earth either. By the way,
you don't even
just as a question, as a quick question.
All right. Do you believe in the heliocentric or the geocentric model?
It's a category error.
Earth? Do you believe in the heliocentric or the geocentric model of the Earth?
A good, simple way of describing the Earth's path is that it orbits the sun, if that's what you want.
I'm saying, do you believe in the heliocentric or the geocentric?
It's a category error. The question is mistaken. There's no one, it doesn't make sense to say I believe in one or the other. It's just a different choice of reference frame.
Now, just to say 1,000 years before Christ.
I have a quick question.
Hold on. Hold on.
Okay, you know what? I'll give you one.
Christ, hold on. 1,000 years before Christ, what was the model of the Earth? Was it a geocentric model?
They had a flat Earth model.
Okay, was it the geocentric model?
No, the geocentric model refers to a specific thing in which the sun orbits the Earth and the Earth is a sphere. No, it's neither of those.
Okay, so so let me ask you a question. That's a great question. Now, so you're saying 1,000 years before Christ, they had a flat Earth model, right?
Yep.
Now,
it wasn't really even a model, by the way. It was kind of just like a vibe.
All right, fair enough. What about that model is not true today? What about that?
So that model can't. I'm answering your question.
Hold on, let me be clear for your audience. So I make clear. What about that flat? It's not that hard, sir. What about that flat Earth model is not true today? Everybody.
I'm answering your question. They can't account for time zones. Their model had simultaneous night for everybody.
Okay, so not gravity, not all this other stuff, just the time zones.
Oh no, there's so much that it gets wrong. That's just the simplest one.
Oh, okay. Well, what I'm saying is that model, I can do anything that they used in that model. I can do today, and I use in engineering. Tell me what I can't do. Tell me what I can't
use time zones.
I don't need. What do I need a time zone for?
for figuring out what time it is in different places. Like it just doesn't match
I mean,
reality,
but
right?
Time is a relative thing,
in
right?
No, it's really not. Like the point is that when it's noon in say Los Angeles, it's like midnight in India, which meaning that like when the sun is directly overhead in Los Angeles, the sun is not anywhere to be seen in India. And
but
on
Antarctica
the model,
is 5 months.
I'm in the middle of a sentence.
Sorry.
In the model that the model that people had 1,000 years before Jesus, they didn't think that was possible. They didn't think it was possible for it to be nighttime in one place and daytime in another place.
Okay, so Antarctica, which
are you going to address what I said at all?
What I'm saying, a time zone is fine.
That's
I'm not disputing a time zone. That's not even
right. So that's how we know that their model was incorrect, because it can't account for the observations that we have.
Okay, but you're saying you know that, but once again, I'm saying my model takes into account for the fact that the sun moves in a certain way where the sun revolves around Antarctica and Alaska for 5 months with sun showing, and here in America it doesn't show for 5 straight months. But somehow you believe
that works on a globe. How does it work on a flat Earth?
That's how it works on the flat Earth. That is
I'm
the
sorry.
point.
So what? So do you have a map that you'd like me to refer to that I can see where the sun is?
Go to the United Nations logo. That's the map.
Okay.
The United Nations logo is the map.
Okay, great. I'm sure that this is what you think, and this is not going to go well for you. Let's pull it up. We're pulling it up. Don't worry. I just want to pull up a high resolution version of one because, then more people can see it. That's low resolution. This one high resolution? Okay, this one's pretty good. Great. So you mean this, right?
That is a model. Once again,
that's what you're working with, right?
No, I'm not working with any. I don't work with any.
This is what shape you think the Earth actually is.
I don't know what the shape the Earth is.
Okay, so then why'd you tell me to bring this up?
You said, do you have a map? I don't know what the map is. I'm just saying.
Okay, so you don't think that this accurately corresponds to the shape of the Earth?
What I'm saying is,
or the distribution of continents, perhaps.
I have zero clue about that. Honestly,
I'm sure. Yeah. So do you want to see how the 5 months of Antarctic day works on a globe?
Yeah, I'd love to see that.
Okay, let me see if I can find a useful diagram for you, because it might be tricky too.
So people in Antarctica are sticking to the Earth underneath us, right?
Well,
people in the South Pole are sticking. They're sticking to the ground. Like I'm sitting in my chair. I'm sticking to the chair. I'm not falling off the chair. Is that what you're saying?
Yeah. Huh? So down is towards the center. I don't know if you understand that.
I'm sticking to the soft cushion.
Down is towards the center. Do you understand that?
Huh?
Here's a good diagram. Okay. You see this diagram?
I'm sticking to the chair.
This is obviously not to scale, but you see the diagram, right?
It's obviously not to scale at all.
Yeah, like the sun's not that close. The sun's much bigger. But like this is a good way to convey the idea. So see how the axis of rotation in, the red dotted line. Oops, where'd it go? Where'd it come back? Okay. There we go. It's still not showing my cursor, but you see that dotted red line that shows you the axis of rotation?
Yeah, I see that.
Okay, so if it spins, all of those places at the very, very bottom, I wish I could show you my cursor. I don't know why it's not letting me show you my cursor. Come on. Let me show you my cursor. There it is. I saw it for a second. There we go. Okay. So all of the places that are south of this white line here, if it spins, will stay in daylight.
Okay.
And because Antarctica is south of that white line, it's further closer to the end there than that white line is. It will get daylight for more than 24 hours actually, because as the days progress, this relative gap here gets smaller, but still you will have daylight for, roughly 5 months or so, depending on where you are in Antarctica.
Okay.
Okay, so just in that
I
diagram
think it's
that
closer
you
to
have
3
there-
months, but anyway, go
Okay,
ahead.
that's fair enough. Now, in that diagram that you're showing there, right there on the screen, when I look at video from Antarctica, or when I went actually to Alaska and I stayed there and I saw the sun revolving around the sphere, right? Revolving around in a circle. There is no way. First of all, the sun being a gazillion miles away would have to be a spotlight, or it can't be a regular light and be 1,000 miles away and light up everything and not light up the darkness. And this whole thing, the way that you're actually, if it's not it's revolving around, your revolutions are off. You're saying it's doing it, but in real life, the sun does not move around the Antarctica like that. It doesn't move like that. It moves around the circle of around them.
Yeah, it
as
moves.
they're on
It starts off east, and then it goes north, and then west, and then south, and
right.
then east
But
again.
your diagram,
which is exactly what the
those
diagram
two
would
things
show.
That diagram doesn't say that.
Yeah, it
and
would.
that-
Yeah, it does.
Are you?
You just have to use your spatial awareness a little bit,
No, you don't.
which I imagine
not
you
a little
have as a
bit.
civil engineer, right?
Okay, now you just want me just to drop all sense of sensibility.
I mean, like if you were standing, oh, you can't see my diagram again. This is so annoying.
If
you were standing, say here, then
upside
initially,
down, stuck to the
so
earth.
yeah, you're standing upside down. Initially,
and I'm
the
stuck
sun-
to the earth, right?
Yeah, definitely. Initially, the sun
Are
would
you
look
stuck
like
to the earth?
yes. Initially, the sun would look like it's south, and then 12 hours later, you would be over here, and it would look like that it is north. I'm sorry, I got that
Upside
backwards.
down.
Over here, it would be north. Over here, it would be south. So over 24 hours, it would go from appearing that it's in the north direction to appearing that it's in the south direction. And then if, this is a 2D depiction, so it's hard to show. But once you got to around here, it would be like it is in the east direction. And when it's on the other side, it would be like it's in the west direction.
Do you know how far the sun is supposed to be away from the earth?
Around 93 million miles, yeah.
So you're saying this 93 million mile away light is just very calmly just moving around the circle of the earth in these perfectly generated spheres, and it's all perfect.
Your
and
incredulity is not an argument. It only shows your ignorance.
I'm just asking you a question, okay? Like, what is this? What is this demand to sort of like vilify the other side? What is that demand about? You're like, everything you say is like somehow, well, you're just stupid, and you're a dumb engineer, and you're dumb. Where'd you get your degree from? Like that, I understand that's the model of how to engage with people. It's just like
Because you're not engaging honestly. That's why.
Because you're just
You haven't been engaging honestly with me this entire time, so
you're
I'm kind of
demeaning
giving
and all
you
this other
back
stuff.
your. I'm kind of
trying
matching
to
the
be
energy that you
as
have.
civil as possible. I'm not demeaning.
Oh no, but you're not. You're engaging dishonestly.
No, I'm
Like
being
every time I bring up something that that contradicts your worldview, you change topics. You try to pivot as hard as you can, or you ask incredulously, "What? So you're sitting? So people down there are upside down? Like it's not an honest engagement with the. It's not an honest engagement with the actual worldview.
That's an honest question.
Yeah, I'm giving you what you deserve because you're engaging dishonestly.
Okay, I can take a 50-pound ball and roll it on the ground, but